Okay, so get this. Today, we're going to deep dive into some pretty cutting-edge AI research. You've probably heard the buzz about AI getting smarter, right?
Yeah.
Maybe even too smart.
Yeah, smarter than us even.
Exactly. Researchers actually call this the gorilla problem.
Oh, that's interesting.
Yeah, it's like the idea that we might accidentally create something that could, outsmart us.
Hmm. Just like we humans have outsmarted gorillas.
Yeah, exactly. It makes you think. And the crazy thing is, AI, it's not just some sci-fi fantasy anymore. It's everywhere, isn't it?
Yeah, it's kind of wild how it's just woven into our lives now.
Yeah, from like personalized recommendations to those voice assistants, I feel like we all use those every day.
It's true. I mean, think about it. We're constantly interacting with AI in some form or another.
Yeah, totally.
And that's largely what we call narrow AI, and AI designed for specific tasks.
Right, right.
But what's really got researchers and all the big tech companies excited and maybe a little nervous is this pursuit of artificial general intelligence.
AGI.
AGI,
Yeah.
exactly.
So that's basically like the holy grail of AI, like a machine that can actually think like a human.
Yeah, essentially. That's the idea, although defining exactly what thinking like a human means, well, that's the tricky part.
Right, because how do you even measure that?
Exactly. Researchers are looking for some key things, like the ability to learn and adapt, to take what you know from one situation and apply it to a completely different one, like we do.
Yeah.
Then there's reasoning and understanding the world on a deeper level, not just processing data. And finally, interacting with the environment in a goal-oriented way.
So not just crunching numbers like a super calculator, but actually understanding the world and acting on that understanding.
Exactly. Bridging that gap
Yeah.
between data and true comprehension. And that leads us to some really interesting research being done at Google
Oh, right.
with Sergey Levine and Kevin Black. They're trying something totally different, focusing on teaching robots to learn through physical interaction with the world, like hands-on learning.
So kind of like how a kid learns through play.
That's the idea. They argue that to really get concepts like gravity or friction, an AI needs to experience them firsthand, not just read about them in some data set.
That makes sense.
Right. So they're robots. They're learning by trial and error, playing around with objects, figuring stuff out for themselves.
I read about that robot that learned to put your watch on a towel,
Yes,
and it had never even seen a towel before. Right?
exactly. Never encountered a towel. And that's a big deal. It shows the robot's ability to generalize,
Oh.
to take what it's learned and apply it to something totally new, and maybe even imagine in a way.
Wow. So it's not just following instructions, it's actually learning and adapting.
Exactly.
But isn't there a risk in making AI more human-like? I mean, we're the ones building this stuff, but what if it gets so smart that it like surpasses our control?
That's the heart of the gorilla problem, isn't it?
Mm.
And it's something that Stuart Russell, he's a leading AI researcher, has been talking about a lot.
Yeah, I've heard of him.
He's saying we need to be super careful about the goals we set for super intelligent AI, if we're not careful.
Because even with good intentions, things could go sideways.
Exactly. Think about it. You task a super intelligent AI with solving climate change.
Mm.
The most logical solution, from its perspective, might be to just eliminate humans altogether.
Yeah.
We're the problem. Even with the best intentions, our goals and the AI's could be totally misaligned.
Okay, yeah, I see the concern. So what are people like Russell saying we should do about it?
He's a big advocate for strong safety measures.
Right.
And tons of testing, kind of like what we see in pharmaceuticals. New drugs go through all these rigorous trials before they're released.
Right, yeah.
We need to do the same with AGI. Make sure it's aligned with our values and won't turn on us.
That makes sense, but wouldn't that slow down progress? I mean, tech companies are pouring billions into AI. They want to see results.
True, there's a lot of pressure to move fast and break things, as they say. But Russell's argument is that rushing ahead without thinking about the risks,
It could backfire.
big time. He even compares it to the development of nuclear weapons, where the lack of foresight led to,
A global arms race.
yeah,
Not great.
exactly.
So we've got these incredible advancements on one hand and these like terrifying potential consequences on the other. It's kind of a tightrope walk, isn't it?
It really is. And the stakes are high. And remember, the future of AI, it's not set in stone. It depends on the choices we make today, the safeguards we put in place, and the conversations we have about this technology.
We need to be having these conversations for sure.
Absolutely.
Okay, so we've got this potential for AI to solve some of our biggest problems, but also this risk that it could create even bigger ones. And at the same time, we're trying to replicate something we barely understand the human brain.
That's a great segue into the next part of our discussion, the quest to actually map the human brain, which could be a game changer for AI development.
All right, let's dive into that, because if we're trying to create something that thinks like us, I guess it makes sense to start by understanding how our own brains work.
Exactly. And that brings us to the work of Ed Boyden at MIT.
Okay.
He's leading this incredible effort to create a digital map of the human brain. It's got huge potential, but it's a massive challenge.
Yeah, I can imagine. I mean, mapping the brain. How do you even start with something that complex?
Well, to give you an idea of the scale, we've only managed to fully map the neural circuitry of a tiny worm.
A worm.
Yeah, and it only has 302 neurons.
Okay.
The human brain has over 100 billion. It's like comparing a grain of sand to the Sahara Desert.
So we're talking about a whole other level of complexity. How is Boyden even tackling this?
He's come up with this wild technique where they actually physically expand brain tissue.
They, what? Expand it?
Yeah. They use this material called sodium polyacrylate. You know what that is?
No.
It's the stuff in diapers.
Diapers? Seriously?
Yep, seriously. It's amazing stuff. It can absorb water and expand up to 1,000 times its original size.
Wow.
So they install this material into preserved brain tissue, add water, and...
They basically inflate the brain like a balloon.
Exactly.
What happens then?
Well, that expansion lets researchers see individual neurons with powerful microscopes. It's like zooming in on a Google map, but for the brain.
So they can see all those tiny neural connections in detail.
Yeah, it's amazing. They've created these stunning images of expanded mouse brain tissue with color-coded neurons, like a beautiful tapestry, but it's a brain. And this is just the beginning. The goal is a complete 3D map of the human brain, a blueprint of our own intelligence.
That is incredible. Consciousness? Or is there something more to it, something uniquely human that we can't just recreate?
That's the question, isn't it? And it's something that Boyden's research might actually help us answer.
It seems like the more we learn about the brain, the more we realize how much we don't know. And that kind of brings us back to the gorilla problem.
Right.
If we're still so far from replicating our own brains, what does that say about truly human-like AI?
That's a big question. And it's one we're going to explore further in the next part of our deep dive. We'll look at the differences between biological and artificial intelligence, and whether machines can ever truly think like us.
So we just finished talking about how complex the human brain is. It really makes you wonder if we're getting ahead of ourselves, worrying about some super intelligent AI taking over when we haven't even figured out our own brains yet.
That's a good point.
Yeah.
I mean, thinking about that future where AI surpasses human intelligence, it's important. But we shouldn't forget about the issues we're dealing with right now.
Yeah, the stuff that's already happening.
Right.
So what are some of those immediate concerns? I know we can't really talk about, ethics and biases and stuff.
Right, of course. But we can definitely talk about the challenges of actually controlling these increasingly complex AI systems.
Okay, yeah.
As AI takes on more and more, ensuring it's reliable, predictable, that becomes critical. Think about a self-driving car, right?
Mm-hmm.
Making split-second decisions in traffic. The stakes are high.
Yeah, for sure.
Those algorithms have got to be rock solid.
Right, because even a small error could be disastrous. So it's not necessarily about, malicious AI taking over. It's more about those unintended consequences.
Yeah, exactly. From AI that's just become too complex for us to wrap our heads around.
It's like building a skyscraper without understanding the engineering, right?
Perfect analogy. You might get it to stand up, but one strong wind.
And it all comes crashing down.
Exactly. We need to approach AI development with a deep understanding of its limitations and where things could go wrong.
Okay, so less Terminator and more about making sure what we build is safe and actually helpful.
That's the goal.
Yeah.
And that requires a shift in focus. It's not just about pushing the limits of what AI can do. It's about making sure what we create is actually beneficial and doesn't pose a threat.
Like the old saying, just because you can doesn't mean you should. We really need to think about the implications here.
Absolutely. And this is where researchers like Melanie Mitchell come in. She argues that getting caught up in these doomsday scenarios can distract us from dealing with the real practical challenges of AI, integrating it into our lives responsibly.
So instead of the robot apocalypse, we need to focus on making sure AI is actually serving humanity's best interests, right now.
That's it. We should be having these conversations about AI's societal impact, how it's used in decision-making, making sure it benefits everyone.
It's like we're at this crossroads. One path, AI revolutionizes healthcare, education, improves lives.
Right.
But the other path, there's misuse, unintended consequences, maybe even a loss of human values.
powerful way to put it. And the path we choose, it depends on the decisions we make right now, the research we prioritize, the conversations we have about the future we want with AI.
It all comes back to that question of what does it even mean to be intelligent?
Right.
If we don't even understand our own intelligence, how can we create a machine that replicates it?
The million-dollar question. And it's fascinating. Researchers across so many fields.
And speaks of challenges, we were talking earlier about Ed Boyden's project, mapping the human brain. That sounds incredibly difficult. Where does that research stand now? What are some of the hurdles they're facing?
Well, remember, the human brain is probably the most complex structure we know of.
Yeah.
Mapping it at the level of individual neurons, it's almost unimaginable in scale.
So how are they even approaching it?
It's a combination of these cutting-edge imaging techniques and computational analysis. One of the biggest challenges is just the sheer amount of data. A tiny piece of brain tissue, just a cubic millimeter.
Yeah.
Millions of neurons, billions of connections. Just processing that information is insane.
It's like trying to create a Google map of the entire planet, down to every house and street at the same time.
Exactly. And then there's understanding what those connections mean. Even if we could map every single neuron,
Right.
we'd still have to figure out how they create thoughts, feelings, behavior.
It's like having a puzzle with billions of pieces, but no picture on the box. You might put it together, but would you really understand what you're looking at?
That's a great analogy. And that's what makes brain mapping so challenging, so fascinating. It's not just about the data, it's deciphering the brain's language, cracking the code of who we are.
It sounds like we're still at the beginning of this journey. Are there any practical uses for this research yet, or is it mostly just scientific discovery?
It's a bit of both. We're a long way from a complete brain map, but what we're learning is already impacting fields like medicine and AI.
Oh, really? Give me some examples.
Well, in medicine, it's helping us understand and treat neurological disorders like Parkinson's, Alzheimer's.
Oh, wow.
By figuring out which brain regions are affected, researchers can develop better treatments.
So this research could actually lead to breakthroughs for some really serious diseases. That's amazing.
It really is. And for AI, it's providing insights into how biological intelligence works, which could help us build more advanced AI systems, more human-like even.
So it's a two-way street. We're learning about the brain to build better AI and using AI to understand the brain better.
Exactly. And as our understanding of the brain grows, the possibilities for both AI and neuroscience, they just keep expanding.
This deep dive has been quite the journey. Gorillas in London, diapers, mapping the brain.
It has been a whirlwind.
And it feels like we've just scratched the surface. We still got so much more to explore.
So much more.
But before we jump ahead, let's recap what we've learned so far. We talked about the gorilla problem, right? The idea that we could create something that outsmarts us and what the consequences might be.
We also talked about focusing on the challenges we have now with AI.
Right, making sure it's safe, reliable, beneficial to humanity.
And then we dove into brain mapping, exploring the complexities of our own intelligence and how that could help us develop even more sophisticated AI.
It's been a wild ride through cutting-edge science and big ideas, and we're not done yet. In the next part of our deep dive, we're going to tackle some even bigger questions about the future of AI, the nature of consciousness, the relationship between humans and machines.
It's going to get really interesting.
All right, welcome back to our AI deep dive. We've talked about superintelligence, mapping the human brain, all this crazy stuff. Now I kind of want to step back and look at the bigger picture. What does this all mean for us, for humanity?
Well, that's the question, isn't it? It's something philosophers, scientists, even the sci-fi writers, they've been thinking about for ages.
Yeah, for sure.
And with AI evolving so fast, it's becoming even more important to figure out.
I was reading about this idea of the singularity, like where AI becomes smarter than humans and everything changes.
Oh, yeah, the singularity. It's a fascinating concept and a bit controversial.
Right.
Some people think it's inevitable. Others, well, they think it's just, speculation.
Yeah.
But whether it actually happens or not, it really forces us to confront some big questions about intelligence, consciousness, even our place in the universe.
It's like we're living in a sci-fi movie, except it's real. And we're not just watching, we're actually shaping it.
That's a great way to put it. We're not passengers on this ride. We're the ones building the roller coaster. And that means we've got a huge responsibility.
Because the choices we make now, they're going to determine where AI goes and how it affects our world.
Exactly. That's why we need to be having these conversations about the impact of AI. considering all sides, the good and the bad.
We've talked about that gorilla problem, right? Creating something that could outsmart us. But even if that doesn't happen, there are other things to worry about.
Oh, definitely. One big one is the potential for AI to make existing inequality even worse. If we're not careful,
Yeah.
it could end up concentrating power and wealth in the hands of just a few.
It's like any powerful technology, right? It can be used for good or for bad. It depends on who's controlling it.
Exactly. And that means thinking about the values that are built into these AI systems, who's designing them, who benefits from them. Those are important questions.
It's not just about the tech itself, it's about the social and economic impacts too.
Absolutely. AI is reshaping our societies, our economies, even our understanding of what it means to be human.
Which brings us back to that question, if we're so far from understanding our own brains, what does that say about creating truly human-like AI? Can we really do it?
It's a tough one. I mean, consciousness is so complex. I think it's more than just neurons firing. Our experiences, our emotions, our creativity,
Yeah.
those things might be impossible to replicate.
It's like there's this magic to consciousness, something we can't just code into a machine.
Maybe. Or maybe we just haven't figured out how to do it yet.
And that's what makes it so interesting. We're exploring this unknown territory, grappling with questions that have been around for centuries.
And the answers we find, they're going to shape human history.
So let's wrap up our deep dive with a few takeaways. First, AI is changing fast, and it's already having a huge impact.
Second, the future of AI is in our hands. The choices we make now, the research we do, the ethics we consider, they all matter.
And finally, understanding intelligence, both human and artificial, it's one of the most fascinating and important things we can be doing right now.
The answers will shape not just technology, but humanity itself.
Thanks for joining us on this deep dive into the world of AI. We hope you've enjoyed it and that it's given you some things to think about.
Keep exploring, keep asking questions, keep pushing the boundaries. That's how